Now you might be wondering, what is an ellipse? Well, let me give you the technical definition, and it's going to appear on your screen. So we'll start with this. An ellipse is the set of all points in a plane, the sum of whose distances from two distinct fixed points called foci is constant. Okay, so while that's still on the screen, let's kind of walk through that. It's the set of all points on a plane, flat surface, like this bulletin board thing here, and the sum of the distances from those 2 points, and those 2 points are called foci. It's plural for focus, so we have more than one focus, and that is a constant number. So let me demonstrate what that means. Okay, we have a flat surface, like this paper, and we're going to have a set distance in between 2 fixed points. These 2 fixed points are the thumbtacks, and the distance in between them is this dental floss that's tied together. So here's what's going to happen. We're going to put these 2 things down, but not that far apart. We're going to put them about like right here and about right here. And what we're going to do is have a constant distance, total distance, from these 2 points. So let me grab a pen and I'll show you what I mean. Because the length of this dental floss doesn't change, we can pull it tight, and we can do this right here. There we go. Okay, now that's the top half. Let's swing around and get the bottom half. Now if I do this just right, it should meet up here at the edges. Whoa, and something slipped. Man, that messes everything up, doesn't it? Okay, well, we're going to go with it. It comes around that way, and it's not too horribly bad down there. But basically, the knot slipped, and it would connect all the way around. And so this is an ellipse. Now, you're probably thinking, no, that's an oval. Sort of the same thing. So let's give a few more definitions. First of all, before we give those definitions, let's label some points here. This point right here is called one of the foci. It is a focus, and here is the other focus. And again, the plural for focus is foci. There is an obvious point on our ellipse, well, in our ellipse, and it is in the middle. So what I'm going to do is just measure the distance between those 2, and that looks to be exactly 10 centimeters unless I'm looking at it at an odd angle. So at 5 centimeters, we have a center. So the center of our ellipse is right here. It's halfway in between the foci. Let's label a couple other points. One of the points we need to label, by the way, you already have this picture on your paper, as you can tell, and so you can just start filling in some of these things. I had to draw it first, but you don't have to because you already have yours. Let's draw this one. Let's draw it in blue. We're going to go this entire distance right here. Let's go this entire distance. And at the ends of this, the longest axis, we're going to put a dot here, and we're going to put a dot here. And this is a vertex, and this is also a vertex. This, of course, is the center. I'm not going to label it the center because it's rather obvious from the picture. And while we're at it, what we're going to do is draw this. It needs to be perpendicular to what is my blue line. And it's going to go right here. And then we'll start labeling some things. There we go. So, here's the next definition. The vertices of an ellipse are the points of an ellipse that are the furthest apart. Any 2 points you pick on this ellipse will not be as far apart as these 2 right here. So these 2 points are the furthest apart. Okay, let's keep going with this idea. The length between this vertex and this vertex, as said, is the longest possible distance in this ellipse. And this is called the major axis. The major axis is the longest chord, and it goes through the center of the ellipse. Longest chord through the center of the ellipse. It will intersect the foci and the vertices, And it has a length of 2a. Oh, Mr. Reader, what in the world is 2a? Well, let's explain. We're going to call this length right here, from center to vertex, A. So the major axis goes from here to here, and because this is truly the center, then this is also of length A. Alright, let's keep going with this idea. The minor axis is the chord that's perpendicular to the major axis, meaning I could put a little right angle right here. Don't want to, it'll clutter things up. But it's perpendicular and it goes through the center. This, of course, is the shorter axis, and it has a length of 2b, which means we're going to split it up into two sections. This distance is b and this distance is b. So the long one is a, the short one is b. That's going to come in handy when we get to the equation in just a moment. While we're drawing on the picture, let's identify something else that's going to come in very useful in a minute. This point right here, this focus and this focus. Let's kind of make them a little more pronounced on mine at least. The distance from the center to either focus is known as C. Now before we get carried away with the A and the B and the C and the right angles, it looks like something's going to be Pythagorean, and it is, but A, B, and C are going to be redefined. Okay, let me develop that idea really quickly. The distance from here to here is C, the distance from here to here is B, and the distance from, and we're going to draw it as perfectly as possible, the distance from here to here can be found using the Pythagorean theorem. But now I want us to keep in mind that normally with the Pythagorean theorem we're using A, B, and C, but now we've redefined A, B, and C. So it's going to be based on the Pythagorean theorem but be using the letters, it's going to use the letters in a different way. So what we're going to do very quickly is figure out what the length of that segment is in terms of C and B using the Pythagorean theorem. The length of this segment would be, let's see, it'd be C squared plus B squared, and that would equal the length of this segment squared. So whatever this is, we'll call it, I'm making up another letter, it'll be D squared. Well, if we wanted to know the actual length of this, it would be, let's solve it, C squared plus B squared, and it would be the square root of that. So this length is C squared plus B squared, all square rooted, and it can happen here as well because it's the same. The square root of C squared plus B squared. Alright, let's develop another idea very quickly. Knowing that every single point on this ellipse was made with the same piece of dental floss that stayed until it slipped at a constant length, then this distance right here, the total of these two pieces, is the length of my dental floss. Okay, when we had the thumbtacks in here, we had one here, we had one here, we pulled the dental floss tight, and it was these two distances added together. So let's just go ahead and start writing that. We're going to develop a formula that's going to come in handy in just a minute. 2C squared plus B squared. Okay, this is the length of our dental floss. Well, let me tell you what else is the length of our dental floss. If I can kind of set this thing back up. When we were setting this up, we got over here to this vertex, this little piece kind of wrapped around here, it went like that. It wrapped around here, and if you wanted to, you could have pulled it tight, and it was 2A. The length of our dental floss is 2A. Now, mine came untied, so it's a little longer because a little bit of it was used up in the knot. But, basically, the dental floss is 2A. And it can be demonstrated here. If we were to set this down and fold this straight out, and fold it back under, right here, it would reach back to that point, which if pulled this way would be 2A. Okay, here's where I'm going with this. If that made no sense, just pay attention to this. This was the length of our dental floss. This is also the length of our dental floss. Okay, let's solve. Let's divide by 2. C squared plus B squared equals A. And then we look at this and say, well, you know what, that square root's kind of making me angry, so let's square both sides. And C squared plus B squared equals A squared. Now let's go one more step with it. C squared equals A squared minus B squared. Now it is very counterintuitive to think about this while thinking of the Pythagorean theorem, but I want you to understand what A, B, and C are. So wherever you wrote this on your paper, I recommend that you also define a few things. C is the distance, going to abbreviate it, from the center to either of the focal points, the foci. A is the length of the major axis divided by 2, because it's really half the major axis. Same with B, minor axis. Length of the minor axis divided by 2. Okay, also on your paper are some formulas. And I want to develop these ideas just a little bit before we move on to the next video. One of the formulas, and you can see it, but I need to take the time to write it. One of the formulas is this: x minus h squared plus y minus k squared. That one's over, b squared. That one's over a squared, and that's equal to 1. Okay, for just a second, let's compare this to the formula for a circle. The formula for a circle was very similar, but did have some glaring differences. When it was a circle, it could equal anything. But if it's an ellipse, it has to equal 1. So later on when we're solving some of these problems, we better make it equal 1. Okay? This is true, this is the equation, if the major axis is horizontal. And I remember telling you that A, and I just told you and wrote it down, that A is half the length of the major axis. So notice that this is if the major axis is horizontal. So if it's horizontal, that's X, then A, being the bigger number, is underneath it. If it's vertical, and you can see the formula on your paper, and you know where I'm going with this, then that's the minor axis, meaning the horizontal is the shorter one, and vertical, being the Y thing, the Y part, is the taller one. Very quickly, I just want to say one other thing. If your graph is centered at the origin, then you're just going to have, let me write that down, if it is centered at the origin, then your graph will follow these equations instead. It's going to be that, or it's going to be this turned around. There we go. Because, and we know this, you know this from the circles, but I'm just going to state the obvious. HK is the center. And again, let me state one more obvious thing. The signs are opposite.